Okay, so let's start. So, okay, we start with this question that I left you guys with in the previous class. And in this question, what they're saying is find the area bounded by the graphs. You have this is the sine function, and that is the cosine function. And then we're given some form of a range here, just to control what we're doing. Otherwise, this would be endless because we know sine and cosine are just repeating functions. Now, what is happening here? How do we actually work out these questions? Well, it starts with having an idea of what really is happening here. That is a picture of the whole scenario. Now, how do we get a picture? So in the first part, we just want to sketch these graphs. So let's sketch the two functions, y is equals to sine x and y is equals to cos x on the same graph. Okay, so this is something like this. So let's start with the graph for sine. So you know sine starts from 0. So I'll put this to be okay. Just a minute. Can you guys hear some noise in my background? Or is it okay?
It's okay.
Okay. Nice. So what we have here is this is pi over 2. Or I can use, yeah, that's pi over 2. That's 90. And then we have this is pi at 180. And then we have that's 270. Is it 3 pi over 2? And then lastly we have 270, 360, I mean. So 360 somewhere here, or 2 pi. Okay, so these are the key points that I want to show. Then we have all the way up to there. Now, of course, we know the maximum point is going to be 1. Like that, then like this, then like that, then back to that point. Okay, so that is sine. Now, how about cosine? Well, for cosine, we know cosine starts from 1. Okay, so that is in the question. We're being asked for, sorry for that. Let me just, okay. So yeah, in the question, we're being asked for the area bounded. What does this really mean? Well, the area bounded here implies the area completely enclosed by these graphs. So which sections do we find the area bounded? You see, because they're saying just the two graphs or just those two graphs, this area we're looking for, it has to be solely enclosed by these two graphs. Now, if you wanted to just find areas somewhere between these two graphs, you'd start with here, and then you'd also look for this area here. This is also between the two graphs. And then you'd also perhaps talk about this one here, up to somewhere here, because the range that we're given is up to 2 pi. But you have to see that there's something wrong here. If you look at the regions I have labeled here, not all of them are actually true or are what we are looking for. Let me label this as A, and this as B, and this as C. Which of these areas are actually what we are looking for? What can you guys say? Which of these areas are what we are looking for. Not everything here works for us. B. Yes, B is what we are looking for. Now, why not A? Why not C? What's wrong with those two sections? Why not A and C? What you have to get here is we want a section that is completely bounded by the graphs. So if you were to consider C here, for example, if you were to consider C, this part, yes, it is bounded by the two graphs, but look at what happens at 2 pi. At 2 pi, C will have to now be closed by this line here. So this part is not enclosed, or it now brings about a new boundary. We want the two graphs to be the boundaries only. So this would mean that a new boundary here will have to be used. So because of that, C cannot qualify. It's the same thing for A as well. A, the top part, yes, is the cosine function. The bottom part, yes, is the sine function. But look at this part. This is the line, y is equals to 0. And that is not the sine or the cosine function. So this region A is not bounded by those two graphs only. So this is why we drop out that part as well. So to work out this question, all we're looking for is the area that is labeled B. So not C, not A, just that part. So that's the first thing that you had to understand for you to work out this question. Now, if you get this, the next part now is to actually work it out. So of course, not to say you need two functions, f of x and g of x. It doesn't matter which one you assign as f of x or which one you assign as g of x. But for this case, I will assign f of x to be the cosine function and g of x to be the sine function. Once you have these, you know to say the area bounded is going to be the integral from a to b, and then you have one function, the one on top, minus the one down. Then with respect to, because this is in the x-axis, so here we'll say dx. So my values of a and b will be x is equals to something, and my b will be x is equals to b. So in the x, we're changing from x is equals to a to x is equals to b. But which function is on top? So if you look at this graph that I have here, white is the function on top, or that's the graph on top, and white is the sine function. And the sine function is g of x. So because of that, I will have g of x here, minus the function down. Red is the function down, and red is the cosine function, and that is f of x. So I end up with f of x here. So this is the integral we're performing. But we know what f of x and what g of x, we know what they are. The only thing that is now left is what a is and what b is. So for f of x and g of x, let's plug them in. G of x, we got to say that is the sine function. So this is sine x minus cos x. Then we have dx here. But now, what is a and what is b? So how do we find those two? What do you think? See, to find those two, you observe that they talk about the only 2 points when the two graphs are the same, or when the two functions are the same. So I want to equate sine and cosine, or f of x and g of x, so that I find the points when they are actually equal. So at what points Let's push this all the way out. So at what points do I expect g of x to be equals to f of x? So g of x is sine x, and f of x is cos x. So all we're looking for here is, for what values of x do we expect these two to be equal? Now, how do we work out something like this? Well, you might have a number of ways of working it out, but one way is to divide both sides by cos so that you end up with sine x over cos x is equals to 0. And we know to say sine x over cos x, that is tan x. So you can approach it from this point, or you can approach it still from this same fact here. So if you viewed it from here, now the question is, for what values of x do you expect this? Yes, please.
Isn't it 1?
1. X is equal to 1.
No. Sin x over cos x is equal to 1.
Oh, yeah, sorry. Yes. Sine x over cos x. You're dividing, so the right-hand side will remain 1. Yes, this is equals to 1. Thank you for that. Okay. So, yes, this is where we are. Now, of course, if you simplify this, I will have at this stage prefer the tan part. Tan x is equals to 1. Now you're asking yourself, for what value of x will tan x give you 1? What do we expect there?
45.
45. So we expect this to occur when x is equals to 45 degrees. But 45, of course, in radians, this is just pi over 4. But we expect two values there, because even when you look at this, you expect 2 points. Clearly, the 45 that we have found is just the first point. So we can say 45 is the one here, pi over 4. But how about the second one? Where is it? Or this value here? Where is this one? How do we find that second one? So how would you get that one? So you have to see that tan will be positive in 2 places. So tan is positive here. So if this is in the first quadrant, that is why that angle is less than 90. So tan will be positive here. It will also be positive if the angle is actually evaluated in the third quadrant. So if the 45 was here. Now, if 45 is here, what would be the angle measured from the positive x? From the positive x, this would be 180 plus 45. In other words, the second angle, the second value of x will be 180, which is pi, plus 45 again, which is pi over 4. So if we do the math here, this is over 4, and then this is going to be 5 pi over 4. Is that okay? So that is the second value for which tan will give us 1. Of course, this is just in the specified range. Otherwise, there are more values that we can actually find there. So once you have the two values, now you have what A is and what B is. So our integral can now be evaluated. Okay. So we can now evaluate our integral. So we know what A is. So this is from pi over 2, pi over 4, I mean, to 5 pi over 4. So let's Okay, and let me just cut these out. Okay, I'll get them back. Okay, so this now becomes the integral of sine pi over 4, 5 pi over 4 of sine dx minus the same for cos. Then this is cos x dx. So the integral of sine, we know it's negative cos. So here we get minus cos x, then from pi over 4 to 5 pi over 4, then minus the integral of cos, that is sine. And then this again from pi over 4 to 5 pi over 4. Okay, so we just simplify this. So you bring in the limits. So this is cos 5 pi over 4, and then minus that negative there. We can do this. Then minus here. Then we have sine 5 pi over 4 minus sine pi over 4. Okay, so this is all we have to evaluate. So you have to remember, you can do this with a calculator if you are allowed that, but if not, you can still evaluate this just by observation and remembering what these are in terms of quadrants. So don't forget that this is still based on how I found it earlier on. It was just 45, but just in the third quadrant. Remember how I found it? It was 45 just here in the third quadrant. So if I wanted to evaluate what these are without using a calculator, all I would need to know is sine 45 is equals to 1 over root 2. So I can take 1 over root 2, or if not 1 over root 2, we can still work with root 2 over 2. Okay, so I can still work with root 2 over 2. So let me get this one. That's what sine 45 is. And cos 45, which is 45 is just pi over 4. And cos 45 would be the same thing, 1 over root 2. But in the third quadrant, sine and cos are both negative. So if I had sine 5 pi over 4, this would be equals to negative the same thing, negative 1 over root 2. And cosine 45, which is 5 pi over 4, in the third quadrant, this is in the third quadrant, this would also be 1 over root 2. This implies that you can actually evaluate these without a calculator. So your answers would be minus the first one, cos 5 pi over 4. We saw this is minus this. Minus. Then we have cos pi over 4. Cos pi over 4 is cos 45, which is 1 over root 2. Minus the second part, sine 5 pi over 4. Again, this is negative, so we have minus 1 over 2, and then minus, this is sine pi over 2. Again, that's 1 over root 2. Okay, now we just simplify these. So the minus will just make sure that everything here is positive.
Oh.
So you end up with, yes, please,
I have a question.
go ahead.
Okay. Regarding how you have, yeah. Okay, go ahead, bit out. When you are substituting,
Yeah.
So you didn't. Is this okay? Is what you've done the same as saying cos 5 pi over 4 minus sin 5 pi over 4, then minus uh cos pi over 4 minus sin pi over 4.
Okay, say what you're saying there. Go ahead.
Is what you did there
Mm-hmm.
the same as saying negative cos 5 pi over 4 minus sin 5 pi over 4 everything minus
Everything,
everything as everything, like everything that is written minus
everything here minus.
everything that is written so far minus
Okay.
uh minus cos negative cos pi over 4 minus sin pi over 4.
Like this.
Hmm.
Okay. So let me try to see how you ended up here. So what you did is you integrated everything and then just kept the limits outside first, right?
Hmm.
So you started it from somewhere here, I guess, somewhere here, right?
Mm-hmm.
So this is where you started from, but you integrated first so that this was minus cos x, this was minus sine x, and then you had pi over 4 and 5 pi over 4, right?
Yeah.
Now you plug in the 5 pi first, which gives you this, and then minus, then you plug in the pi over 4 next, which gives you this. Ideally, it's supposed to be the same, but is it the same? Okay, let's see. Yeah, ideally, it's supposed to be the same. Yeah, but if you simplify this will be minus. Let's do the math. This will end up, this is, remember this, what we said about this one, huh? Because 5 pi over 4 will give you what? Positive, right? It will give you positive with this minus outside, right?
Mm-hmm.
So this will end up being just 1 over root 2. Then this one again, it's in the third quadrant, so we expect it to be negative. So again, this will be positive, 1 over root 2, right? Or perhaps I should say minus 1 over root 2 for cos 5 pi over 4. Then minus again, this will be 1 over negative root 2, and this is this one. Then minus negative, the first one again, cos pi over 4, that's cos 45, which is 1 over root 2. Minus, again, sine pi over 4, that's again 1 over root 2. Do you see, what do you think? Are they the same?
Yeah. Sorry, I
Are
didn't
they?
see what you found, please.
Pardon? Oh, okay. So let me simplify this one first. When you send in the minus, this becomes plus this, then plus this, then plus this, then plus this. And this here will be same denominator, so we have root 2. And then when you add there, you get a 4. Okay, you guys can verify what we've done if it's correct. But let's see what I was doing here. So what I was doing here, do you see that it actually reduces to the same thing?
Yeah.
Yeah, so even this would reduce to the same thing. Okay, so yeah, even this would end up giving us 4 over root 2. If you wanted to rationalize the denominator, you should see that this could be written as 4, multiply the numerator and the denominator by root 2. This would end up being root 2 on top over root 2 times root 2 down, which would end up being 4 root 2 over 2. The 2 and this would simplify to give you 2 root 2. That is if you wanted to rationalize the denominator. But still, this is fine. You can still present that as the final answer. This is fine. Any questions there? Okay, so that is sorted out. Now, there are a number of questions that we can do, but I think what we have done so far generalizes the concept of area and how to actually work with it. So next up, we now want to start looking at volumes. So volumes of revolution and how to actually determine them. Okay, so this is where we are now going towards. Okay, so let me try to get back the diagrams that I deleted earlier.